Hello, welcome to another video. This is Arjun with SciKids, and today I'll be showing you water purification. So, for this water filter, we've talked so much about the properties of water and how important a role it is in sustaining life on Earth. A lot of times, though, water might not always be available for use in many places around the world, and the water that is available may not always be clean. At a commercial scale, there are various methods that can be used to clean or recycle dirty water. In our daily lives, the water that comes through our taps have undergone extensive purification steps. In this experiment, we'll be making our own water filter using materials that are easily available around us. So first we'll need one 20-ounce water bottle. So we cut off the bottom, and you'll need to keep the bottom of it in order to use as a base, as you'll see later on. So I'll just put it like this for now. And then we need some sort of like cheesecloth or gauze, a rubber band, some cotton balls, then some activated charcoal, small pebbles, like very small, like this size, some medium pebbles, some large pebbles, and then some of these other rocks. So now we put the gauze or cheesecloth over the hole of the bottle, and then we wrap the rubber band around it, just enough times for it to become completely secure. And this just ensures that when we flip it over like this, that nothing falls out except for the water, which is desired. And now we begin to put in our layers, and so we start with cotton balls. Then after the cotton balls, we move on to the activated charcoal. So we just want to make sure that we get a good amount of it in, but not so much that we can't add anything else. So we can just mix it around and make sure that it's dispersed evenly. And now we're going to add some of this back because I accidentally added a bit too much in. So now that's a good amount. So now we're just going to add in some of these smaller pebbles. Gotta make sure that this thing stays balanced. So we just add in a decent amount of these small pebbles. So about that much. And then we move on to the medium pebbles. So we add in a good amount of that. But we need to make room or leave room for the others. And then we move on to the large pebbles. So we fill that to a decent amount. A bit more. And then we just add some of these rocks.
and that'll fill up the rest of it. So now we just take some of this water that we gathered from a local lake and we just kind of mix it up to make sure that the sediments are evenly spread. And then we can just pour it into the filter. So we need to make sure that we don't pour too much so that it doesn't overflow. But as it's going down, we can keep on pouring it in. Now just keep on pouring. Alright, and that's all of it. So now we can just let it drip down for a bit. So now that it's roughly done draining for the first round, we can just take it out of this little cup. And as you can see, the water that's at the bottom is a lot clearer than it was before. So now we can just put it back into the cup. And so the water almost looks safe and looks a lot cleaner than it did before. So now we can just put this rock back in and put this little cup back under it. And now we can put it in for round 2. So we can just pour this little last bit back in, and then we can just wait for it to finish draining. So now that it's roughly finished, so we can just let this drip for a moment. And so now once it's done dripping, we can just put this to the side, and as you can see, it's a lot clearer and better than it was before.
Now let's discuss the science behind this. When we first assembled the filter, we made sure to first add the materials with smaller pore sizes to the bottom, and we kept going up in pore size as we filled the filter. As we slowly added the dirty water into this filter, the water slowly moved down the layers. As the dirty water flows through the various layers, the larger particles such as the sticks, leaves, etc. are trapped in the first layer of pebbles. Sand, which forms the next layer, is a very good filter media and can filter out the finer impurities. As the water keeps flowing, the pores of the filter materials get smaller, and smaller sediments will be trapped as the water keeps moving down. We also have activated charcoal in one of the layers. The activated charcoal acts by removing the contaminants and impurities by a process called adsorption. This can catch smaller particles that are too small for us to see, and it can also remove some of the dissolved substances from the water. The cotton balls and cheese keep all the materials inside of the filter. The water that comes out of the filter looks clean, but we cannot drink it at this time. Though all of the visible dirt is removed, this does not destroy the bacteria and other harmful microorganisms. For this, an additional step is needed, where you add a chemical disinfectant such as chlorine to the water, or boil the water before drinking it. Some of the commercially used techniques for water purification are similar to this. Large filtration tanks utilizing sand, gravel, activated charcoal, etc. are used to filter the water. After filtration, a disinfectant such as chlorine is typically added to the water to make it safe for consumption. This also has great applications in real life. Did you know that water filters can be used to save lives? What I have here is something called a water straw. which was developed to make contaminated water safe to drink. So sometimes natural disasters such as an earthquake or flood may make it hard to find drinking water, or we may be traveling or hiking and we may not always have access to clean water. The water straw allows us to drink filtered water from lakes, ponds, etc. that might not otherwise be clean. However, before you use this, you need to rinse it multiple times. These straws use various techniques to filter out water, including membrane microfilters, which have tiny microscopic pores that will filter out the contaminants. I hope this video was informative. Thank you very much.